Hello, and today we'll be doing the following problem. What fraction of the square is green? So as we can see, we have a square here. Let's call this square ABCD. And in our square, we have two segments. We have one segment that starts at vertex A and that divides the side BC into two equal parts. Let's call that point E. And we have another segment that starts at vertex B and that divides segment CD into two equal parts. Let's call this point F. And our two segments AE and BF, they intersect each other. So let's call that intersection point G. Now, since we want to find what fraction or what part of our square is green, it'd be simpler just to make the sides of our square be equal to 1. By doing so, all we need to do is find the area of the green part right here, and we would have the fraction of the square that is green since the area of our square is 1 square unit. So let's look at this green part. So this green part, it's a quadrilateral, but it's not a trapezoid. It's not a parallelogram. It's not a regular quadrilateral, let's say. So perhaps it'd be a little simpler for us to find the area of the white parts of our square first, and then subtract that from the area of our square to find the area of the green part. So let's take a look. So the white parts are actually made of two triangles. Triangle BCF and triangle ABE. And we can find the area of these two triangles quite easy. So let's say they have a base of 1 and a height of 1/2. So 1 times 1/2 all divided by 2 will give us 1/4 square unit. So these two triangles, this triangle here has an area of 1/4 square unit, and this triangle here has an area of 1/4 square unit. But these two triangles, well, part of them intersect each other. So this part right here. So triangle BEG, that would be the intersection part. The part that intersects both triangles BCF and ABE. So if we were able to find the area of that triangle, we will be able to find the area of the white part. So how can we find the area of this triangle? So now if we take a look at these two triangles here, so let's say triangle BEG and triangle ABG, well, these two triangles, they kind of look similar to each other. So if we could show that these two triangles are similar, then we will be able to find the area of triangle BEG because we have their ratio of similarity. So recall that side AB is 1 and side BE is 1/2. And these sides correspond to the hypotenuse of our triangles. So our ratio of similarity would be 1/2. Now, in order to show that these two triangles are similar, what we actually need to show is that this right here is a right angle. So how can we do that? Well, actually many different ways of showing that. So I'm not going to show all of them. This video will be 2 hours long if I decided to show all the different ways. I will show one way rather quickly. But if you can think of another way of showing that these two segments intersect are perpendicular to each other, that means intersect at a right angle, please go ahead and leave a comment. Yeah, sure, leave a comment. All right. So what I'm gonna do the analytical geometry. So we can imagine that segments, let's say FB and EA, are on a Cartesian plane, and we would to represent them as linear functions. So if we look at segment FB, now if we recall a linear function, we can represent it as y equals to ax plus b. So But what we really care about is the a. It is the slope of our function or the unit rate of change of our function. So if you recall, some people learned it as rise over run. Well, now we can actually see it. So this would be the rise, this part right here of segment FB. I'm going from left to right now. That is the standard in the Cartesian plane. So this would be 1/2 right here. So that's the rise, and this is our run, as they say. It would be 1. So the slope of, let's say, the slope of the line that represents segment FB would be 1/2. 1/2 divided by 1. Now let's take a look at segment EA. So EA doesn't rise, actually, it's going down if we go from left to right. So it's not really a rise, it's a descent. So our slope would be negative. So it would be -1 divided, so this is our -1 right here, divided by 1/2, which gives us -2. So if we recall, if we have two linear functions and we take their slopes and we multiply their slopes together, and the product of which gives us -1, then those two lines intersect each other at a right angle. They are perpendicular to each other. Let's call this A1 and A2. So if we were to multiply both our slopes, we would get -1, showing that they intersect at a right angle. And now since they intersect at a right angle, we can show that these triangles are all similar to each other. Triangle BEG, triangle ABG, and triangle ABE. This is beta. I'm not going to go through all of the proofs right here. And as I mentioned before, there are many different ways. So we could use trigonometry, we could use the cosine law to show it, we could use metric relations, we could also use vectors, represent our segments as vectors and find a dot product of them. So many different ways of showing it. And, well, we should solve the problem now. So we have concluded that these triangles are similar, and also we know their ratio of similarity. So the hypotenuse of them would be, the hypotenuse of triangle BEG is 1/2, and the hypotenuse of triangle ABG is 1. So their ratio of similarity, let's put the small on the big, would be 1:2. So therefore, the ratio of their areas would be 1:2 all squared, would be 1:4. So that means that this triangle here, triangle BEG, has an area 4 times smaller than triangle ABG. So if I were to call this x, this would be 4x. And we know that this whole thing here, that whole triangle, well, that has an area of 1/4. So we have x plus 4x equals to 1/4. We get 5/4 on x. We get 5x, sorry, equals to 1/4. So x equals to 1/20. So this part would be 1/20. So this part right here, triangle ABG, would be 1/4 minus 1/20 gives us a fifth. So this part right here as well would give us a fifth as well, because triangle BC, oh, what's my F? BCF has an area of 1/4. So the area of the green part would be 1 squared minus 1/5 plus 1/5 plus 1/20. And that, so all of this would give us 9/20. And we get 11/20. And that is the fraction of the square is green. Now, if you see my previous videos, you would have noticed that the problems I did before were very similar actually. So this is the problem I did in my previous video. So we have actually, it's very similar looking shape. In fact, this is the part that we wanted to find this time. But this time, in this problem, we are already given the fact that these two segments, this segment here and this segment here, intersect at a right angle. So that is the main difference between these two problems. So in order for us to do the problem we have right here, we need to show that now we need to show that this here intersects at a right angle, but we have the additional information that it divides both these parts into equal parts, which we did not have before. If we were to extend this line right here, well, then it would divide this side into equal parts as well. Well, if the side was equal to 1. So there we go. So this was a nice little example. The, the nature of the question has changed given what information we have. So in this case, we had to show that these two segments intersected at a right angle. They were perpendicular to each other. Before, we already had that information. And with that, Matthew Teach You Math, thank you.